do have multiple paths, use the longest path for the timeline below. You can then illustrate how the other paths feed into this line. So here's our VSM example. Now, I'll give you fair warning, there are 17 iterations, so this section is kind of long. The CEO of Simplex Ski Company read a book on value stream mapping and decided to bring me in to help them map their value streams and to create true change in their organization. He takes me for a tour of the shop floor, and this is what I see on day one. Now, I'm just as confused as you are. All I see is a giant mess. The entire shop floor is organized in process villages. In other words, all like functions are grouped into large areas like the cutting area, the tracing area, and the painting area. Notice all the WIP that litters the shop floor. So I convinced the CEO to let me attack one value stream with no distractions or no scope creep. He agrees on the condition that I attack the value stream for the red skis. So as always, I start by scoping my balance. In this case, it's the raw materials area and the shipping area that make up my balance. Now, I walk the process and make sure I have a good feel for how the red skis are made. The CEO has done a good job in assembling a team from each functional area to work with me on the value stream. We start in the raw material areas and walk over to the coating. This is where raw materials are coated with a primer material. Batches of coated material are then sent over to the tracing area. Operators trace out the shapes of the skis on these massive sheets. The trace sheets are sent over to the cutting area where we observe an operator cutting sheets in small batches. The cut skis are sent over to a painting area where a large paint booth gives the skis a nice shiny coat of paint. We walk over to the next station, which is stenciling, and here a couple of operators are proudly stenciling on the Simplex logo on the skis. The final step of the operation involves installing the binding units on the skis. Once this is done, the skis are packaged and sent off to the shipping department to be sent to the customer. Now that I have a good understanding of the process, I'm ready to go back and get some inventory data. So in raw materials, I count 6 red drums of coating. Each red drum can coat 1,400 sets of skis. I asked the CEO how many sets of skis the customer demands on any given day. The answer is 140. Now, even though I'm full-blooded Irish, for some reason I'm pretty good at actually doing some quick math in my head. So 6 barrels times 1,400 sets per barrel gives me 8,400 total units I could paint. I divide 8,400 by the daily demand of 140 and see that they're holding 60 days or 2 months worth of inventory worth of red coating. I do the same thing for the massive fiberglass sheets in the raw material area. There are 5 sheets, and each sheet can produce 1,400 sets of skis. So 1,400 times 5 equals 7,000 sets of skis. I divide 7,000 by the customer demand of 140 per day, and that's 50 days worth of inventory of raw material fiberglass. I walk to the coating area and notice there are neat stacks of 100 sets of skis that have been coated. I count 19 of these stacks, so that's 1,900 sets worth of ski material. I ignore the material designated for the yellow skis because this is not within our value stream. So again, 1,900 sets of skis. I also notice there are 4 that are in process on the work tables of the operators. I add this to my total. So I divide 1,904 by 140, and that tells me there's 13.6 days worth of WIP in this area. I go over to the tracing area, and again, I count the stacks of 100. There are 15 stacks of 100 and 8 in process on the table. So that's 1,508 sets. Before I move on, the material handler comes by and takes a stack away. I ask him if there are more stacks of traced skis. He points over to the cutting area, and there's another holding area for traced skis that are going to be cut. This doesn't surprise me because the plant is running on a push system, so inventory is scattered. I go over and count 10 more stacks of skis that belong to the tracing area. As a quick side note, empty triangles on the floor represent WIP that has not been touched yet by the current station. This means this WIP belongs to the previous station and was merely pushed to the next workstation. If the triangles are filled, it means that the WIP has been completed by the current station and belongs to that operation. Obviously, items being manipulated on the table also belong to the current station. So we have to go back and erase the original number of 1,508 because I found more WIP at the next station. Now do you see why we do this in pencil? So 1,508 plus 1,000 gives me a grand total of 2,508. Again, I divide this by 140, and that gives me 17.9 days. So I'm still at the cutting station, and the operator just finished a batch of 6. I add that number to the 16 stacks of 100 I see. So that's 1,606, and this time I take the initiative to walk over to the next station to investigate if there's more cutting WIP there. My suspicions are correct, and there are 7 additional stacks. So my grand total is actually 2,306, which is 16.5 days worth of cutting WIP. At this particular moment, there are no red skis in the painting station. But But I go to the next station and find that the red painting whip had been pushed to the stenciling station. I counted 14 stacks, or 10 days worth of painting whip. I walk over to binding and there are no red units. I begin to notice a pattern here. Each workstation tries to finish up their work and pass it on to the next station as quickly as possible. This is in an effort to clear their own area and to improve their own work area metrics. So I walk over to the shipping area just to see how many parts binding has pushed on out of their work area. There are 2,400 units, or 17.1 days worth of binding inventory. In this case, it's all finished product. The team and I walk the process several more times to collect information about cycle time, changeover, batch sizes, station uptime percentages, and quality percentages. I also confirmed that the production controller puts out daily work orders to each station via daily schedules. Now, this is what the resulting map looks like. Notice that it takes over 135 days for a red ski to flow from beginning to end in the current state. But the value added time is only 33 minutes. Notice also that the raw materials are delivered weekly or bi-weekly, which forces Simplex skis to use valuable floor space. And finished product are shipped out weekly. Again, production scheduling controls what ships and what is produced at each workstation daily. But a lot of times the information is incorrect and a lot of firefighting has to take place to get the shipment and production information corrected. Now, the CEO is very excited to see his first real value stream map. He envisions cells dedicated to each of his 3 unique product families. He challenges us to create an ideal state map that would support this model. He realizes that given the constraints and the layout of the facility today, this isn't achievable within the foreseeable future. The CEO is also very disappointed that it takes 135 days to convert raw materials into red skis. So he asked us to show him what it would take to make red skis in just 1 day. This is initially met with some raised eyebrows, but we take it on as a challenge and I lead an effort to come up with an ideal state map. The ideal state map includes daily delivery of raw materials, a 3-person cell, and production that is controlled by pull from the customer via sequence Kanban through electronic feeds. Skis would be delivered daily to the customer rather than weekly. So armed with this ideal state map, we're ready to create a future state map. This is what we envision our system to look like 90 days from now. Now, the map does not appear to have changed much. But if you look closely, the team is proposing some significant changes in the form of quality and uptime improvements. So, this is the view of the data from the data boxes, and these highlighted cells are the metrics that the team are trying to improve to reach the future state. The team clearly indicates the areas they are trying to improve directly on the map. This is communicated to everyone on the shop floor by using Kaizen bursts with areas we are trying to improve. This is a view of the 90-day action plan that was driven from the Kaizen bursts. So let's fast forward 90 days, and this is what the shop floor looks like again. It physically hasn't changed much, but the team is excited by our improvements. I go through the same exercise with the team. We walk the process, count the inventory, and validate improvements in quality and uptime. The team met or exceeded each of their goals from 90 days ago. They take time to celebrate their accomplishments with the entire plant. We next decide to attack stenciling and painting. Painting has a long changeover time, and we realize in order to achieve our goal of a 1-piece flow cell, changeover time and batch size must be reduced. There's also a significant amount of scrap that is generated from only having a quality percentage of 94%. The cycle time in stenciling could use some work too. Some Kaizen with the shop floor employees may reveal that we can reduce this 20-minute cycle time in half.